Lesson 7-3, Multiplication Properties of Exponent. So the multiplication property of exponent tells you that whenever you have a number or two numbers with the same base, so the base is the number that the exponents are affecting, so it's the big number. So we have 5 to the third, the 5 is the base, the 3 is the exponent, same here, 5 is the base, 6 is the exponent. Since both expressions have a base of 5, that means that we can combine them. So when we multiply them, the base stays the same, it's still 5, but what we do is we add the exponents. So this becomes 5 to the 3 plus 6 power, which is 5 to the 9th power. Okay, so let's look at this other example. So remember, the base is only the number or variable that the exponent is touching. So in this case, the base is a. 5 is not the base in this case, 5 is the coefficient. So when you're multiplying them, the base stays the same. You still have a, and you can add your exponent, 3 plus 6, but you need to also multiply the coefficients. So this isn't going to be 5a over here, it's going to be 5 times 5. Okay, so your final answer is going to be 25a to the 9th. So remember, if you have a letter, that means you need to multiply the big numbers and add the little numbers. If you don't have a letter, then the number stays the same and you just add the little numbers. So with that in mind, let's look at number 1. So number 1 is 5a to the negative 2 power times 5a to the 6th power. So we have a letter here, and this tells us that this is our base. So our a stays the same. We also have two big numbers, the 5 and the 5. So we are multiplying the big numbers, 5 times 5. We also have two exponents, negative 2 and 6, and we are adding those, negative 2 plus 6. Okay, so our final answer is going to be 5 times 5, which is 25, a, and negative 2 plus 6, that's the same as 6 minus 2, and that is 4. So we have 25a to the 4th power, and that is number 1. So number 4, we have r to the 3rd times r. So anytime you just see a letter or a number and there's no exponent, the invisible exponent is 1. So it isn't going to be r to the 3rd, it's going to be r to the 3 plus 1, and that is r to the 4th. And that is your answer for number 4. Number 7, we have 1 over y to the negative 7 times y to the 5th. So we see the base of y, which means we can add these little numbers, negative 7 plus 5. So what that equals is 1 over y, and negative 7 plus 5 is negative 2. And because this is negative, we want to move this whole thing to the top. We want to flip it to turn this into a positive. So our answer is going to be y squared. And that's number 7. Number 10, we have r to the 6th times a to the 4th times a times r to the 4th. So we can't just combine these all together. We can only combine them if they have the same base. So we have r to the 6th and r to the 4th, and we have a to the 4th and a. And remember, the invisible exponent here is 1. So we have r to the 6 plus 4 power times a to the 4 plus 1 power. And 6 plus 4 is 10, so we have r to the 10th, a to the 4 plus 1, which is 5. So this is our answer for number 10. Number 13, we have f to the 5th plus f squared plus f 0. So what we can do is just have f to the 5 plus 2 plus 0 power. And 5 plus 2 plus 0 is f to the 7th. And this is our answer for number 13. Number 16, we want to simplify each expression, write each answer in scientific notation. So we have 5 times 10 to the 6th times 5 times 10 to the negative 4th. So in scientific notation, remember the first number is going to be in between 1 and 10, and then we have times 10 to a power. So what we do here is we multiply these first numbers together, and we say times 10, and we add the exponent. So we have 5 times 5 times 10 to the 6 plus negative 4 power. Okay, and this comes from here, this comes from here, this comes from here, and this comes from here. Okay, so we have 25 times 10, and 6 plus negative 4 is the same as 6 minus 4. So we have 10 to the second power. But remember, we want this first number to be in between 1 and 10. So we're going to move the decimal from over here to over here. So we move it once, so we add 1 to the exponent. So our final answer is going to be 2.5 times 10 to the third power. Number 19, we have 4 times 10 to the 9th power times 4.1 times 10 to the 8th power. Okay, so once again, we have our big numbers that we want to multiply together, and then we have our little exponents. Okay, and 10 is our base, and that's going to stay the same. So we have 4 times 4.1, okay, times 10 to the 9 plus 8 power. Okay, so 4 times 4.1 is 16.4 times 10, and 9.8 is 17. So remember, this first number needs to be in between 1 and 10. So 16.4 is bigger than 10. We need to make it smaller by moving the decimal 1 place. And since we move it 1 back, we are going to add 1 to the exponent. So we are going to have 1.64 times 10, and 17 plus 1 is 18. And this is our answer. Okay, last one, number 22. We have 6 times 10 to the negative 6, 5.2 times 10 to the 4th. So we have our big numbers, our first numbers here, that we are going to multiply. 10 is our base, it stays the same, and we are going to add our little numbers. So we have 6 times 5.2, okay, times 10, and we're adding our exponents, negative 6 plus 4. Okay, so 6 times 5.2 is 31.2 times 10, and negative 6 plus 4 is negative 2. So because 31.2 is bigger than 10, we want to move the decimal place once. So we have 3.12. And since we're moving the decimal place once, since we're making this number smaller, we're going to make the exponent bigger by adding 1. Okay, so we have 3.12 times 10, and negative 2 plus 1 is negative 1. So this is our final answer for number 22. And that is it for practice 7-3.